third day, first session. So we have the eminent professor from IIT Madras, Dr. Samuel GL, who is currently working as professor in the Department of Mechanical. We are privileged to have Dr. Samuel sir for this third day of session, day one, and he is going to talk about the pillars of smart manufacturing. So let me invite Mr. Ragesh for the giving an introduction about the speaker.
Thank you, sir. Good morning, one and all. It's my pleasure to invite Dr. G.L. Samuel for this FDP. Let me give a brief introduction about Dr. G.L. Samuel. He is currently working as a professor in the Department of Mechanical Engineering, IIT Madras. He has received various awards and honors. The Erasmus Mundus European Heritage Scholarship, funded by the European Commission in 2013, the Brain Korea 21 Scholarship by the Republic of Korea in 2004. He had won the Best Research Paper Award at the International Conference on Intelligent Flexible Autonomous Manufacturing Systems, IFAMS 2000 in Coimbatore, India. The National Merit Scholarship Award by the Government of India in 1986. He has also secured second rank in MTech from the Mysore University in 1994. His book chapters are the measurement systems for characterization of nano-finished surfaces. The publisher name is Taylor and Francis Group. Then the second one is laser micromachining of semiconductor materials, application of lasers in manufacturing in 2019. He has filed many patents. Let me give a brief introduction about some of them. The method and setup for wire electric discharge, double helix turning application. Then the second one is micro nano textured drill bits with MQL system for low and high aspect ratio drilling for super alloys for sustainability. He is also a reviewer for many books like The Tool Design, the third edition, published by Tata McGraw-Hill, then The Machine Drawing, second edition, also by Tata McGraw-Hill. He is also a guest editor for the International Journal of Precision Technology special issue on advances in precision and micro manufacturing. He is also having research publications in the Indian Journal of Engineering and Material Science, published by CISR New Delhi, Precision Engineering, Computer Aided Design, Assembly Automation, Journal of Engineering Manufacture, the International Journal of Automation and Control, the International Journal of Microstructure and Material Properties, the International Journal of Machine Tools and Manufacture, the International Journals of Advanced Manufacturing Technology. He's also having a collaboration or working as a visitor professor for various universities, and I will give a brief of some of them. The first one is the University of North Carolina in USA. During the time from June 2009, he is part of research discussions and planning for MOUs. Then Texas A&M University for research discussions. The University of Technology, Sydney, Australia, during the time period October to November 2018 for research exchange, the key technology partner with UTS Sydney, Australia. Then University of North Carolina during the time period July 2008 to 21 for establishing research collaborations. Then Heathrow Ward University during the time period from September 2010. University of di Milano under the Erasmus Mundus European Scholarship, and the University of di Torino during the time period June to July 2013. Then Chamberlain University of Technology, Sweden during the time period June 2011. This is just a brief description about the works of Dr. G.L. Samuel, and I request Dr. G.L. Samuel for his wonderful section, and I think that the section will be very good for all the participants. Thank you.
Yeah, thank you for that introduction and the invitation. So I'm glad to deliver this lecture to the participants. So the participants are from various universities, is it so?
Yes, sir. Yes, sir.
They're all mostly teachers.
Yes, sir.
All of them are teachers. So it is AICT sponsored. Okay, so I'll be interacting with you during the session, so you can unmute and speak. So it doesn't mean that you have to be participants, means only you have to listen. So, okay. So whenever I ask questions, you can interact so that I can understand you better. Okay, now as they have introduced and you would have seen the topic. So today's topic is pillars of smart manufacturing. So we try to define what is this manufacturing. So today already you are in the third day of the short-term training program. So probably you might have understood what is this smart manufacturing. Can some of the participants say what you understood by the term smart manufacturing? Yeah, you can answer. Please unmute and you can speak.
Sir, you are made a co-host. You have the privilege to mute and unmute, sir.
You have? Can you please repeat?
So you can select any one of the participant and you can unmute and then ask them the question.
Oh, I need to unmute, but they have no right to unmute, is it?
Yes, sir. Yes, sir.
Okay, that's. But you can do that, no?
No problem, sir. I can do it.
Is there
Sir.
any provision for raising the hand or something like that?
They can raise the hands or they can chat.
Okay, so I'll not know who are the faculty or who are the participants. Okay, now Benny Sebastian. Is he participant or some of your faculty also will be here, no?
Yes, sir. Benny Sebastian is our faculty member.
Yeah, see, that's the reason. So, Anu. Okay, Benny Sebastian, yeah.
Benny, you can ask any question.
No, I meant actually for participants, but Dr. Benny, you have any questions you can ask. No, it's the question is what is smart manufacturing? That is my question. Oh, I need to unmute, but they can unmute. No, host can permit unmuting of all. Then only those who need to answer, they will unmute themselves.
So we have made a setting like in order to avoid the disturbances, we have the master
Okay.
control, and the co-host will be also having the master control.
Okay, so how do I unmute? Where is the command?
In the case of there's a participants logo light beneath.
Okay, so this is because I shared this window is maybe this.
Okay, otherwise we will do so. We will change it by ourselves.
Yeah. So George, Nixon George, is he faculty or member? Okay.
It's also our faculty members.
Yeah, I think I remember seeing Nixon George.
Hi sir, good morning.
Yeah, good morning. Okay. So Ajay is our faculty. I need to ask to unmute. Okay. Yeah, Ajay, can you speak? What is manufacturing? What did you understand?
Smart. I'm not very clear, but I believe it is something related to computer integrated.
Okay, so but the speakers in the previous 2 days would have said something, no? So from that you can say what they have told. Okay, so Vanita, is it already unmuted? Pratima? I'm not able to unmute that. Asked to unmute. Okay. Martin, Jose, you're able to see my screen, isn't it?
Yes, sir. Yes, sir.
Yeah. So at least if someone gives an answer, we'll move forward. So to save time, can you please?
So it is the advanced just-in-time manufacturing, like not with
Okay.
the bulk used with batch production, with faster responses and good quality products in the limited time.
Okay, fine. Okay, Ramya Shaji raised the hand. Can you please unmute? Yeah, can you please unmute Ramya?
Yes.
Sir,
Yeah.
sir, is it something related to Industry 4.0 where the manufacturing system changes with the demands and the conditions?
Yeah, so it is okay. Industry 4.0. I'll have a slide to tell you what is the difference between smart manufacturing and Industry 4.0. So I think the participants are more familiar with the term Industry 4.0. Is that right?
Yes, sir.
Okay. So when you're talking about your IoT and all, I think these terms would have come. Okay, I'll tell you later what is the difference between uh, the smart manufacturing and okay, I need to. Are you able to see the PPT clearly?
Yes, sir. What is smart manufacturing?
Okay, is this window of the picture and all, are they obstructing the thing or you don't
No,
see
it is
that?
fine, sir.
Okay. But I can only see your picture there. It's a speaker. Okay, fine. Yeah. So smart manufacturing is a broad category of manufacturing that employs computer integrated manufacturing, high levels of adaptability and rapid design changes, digital information technology, and has more flexible technical workforce training. So just to put it in short, so as you said, smart manufacturing means it is industry 4.0. So the title of your short-term training program is IoT based manufacturing and design challenges and opportunities. So your IoT based manufacturing. So these terms are sometimes confusing, but they are all actually referring to something which is very similar. So the terms smart manufacturing, industry 4.0 and IoT based manufacturing. So these are more or less showing to the same kind of type of manufacturing. So probably after I complete this lecture, all these terms will be clear for you. Okay, so now when you have a smart manufacturing, you need to have a smart industry or a smart factory. So that smart factory is industry 4.0. So where there will be various aspects as you see here. So multi-scale dynamic modeling and simulation will be there in that industry. So if you want to know whether the industry is industry 4.0 or not, you can put all these factors, what you can see on the screen, and then check if they have all those things, it is industry 4.0. If not, you are actually in the lower order. So if you look at the real factories, when you go and then see, so we see few of them in industry 4.0. So others are industry 3.0, and even there are industries which are only 2.0 and probably even 1, some of the industries. So multi-scale dynamic modeling and simulation, intelligent automation, strong cyber security, network sensors, big data processing, industrial connectivity, and then it should also have the advanced robotics. Okay, so that is about smart manufacturing. Now, probably when we go back into the traditional manufacturing and then look at them, probably you will understand what is the significance of this smart manufacturing much, much better. So if you look at a traditional manufacturing cycle, so we will have generally materials and then product research will be going on. Then there'll be a design. And usually if you look at the traditional design, so how all this process of manufacturing starts is by identifying the need, So then we'll have production, product design, then we'll have process planning. So for process planning these days, we have the help of computers, and that will be called as CAPP, means computer aided process planning. So then it moves on to the manufacturing floor. So where we will have different processes which need to be carried out, and then we have different machines. Now, when you want to mount this workpiece on the machine, so we need actually the tools, we need the jigs, fixtures, and then we need the tools to cut that material, and then we need automated systems actually to transport the material from one end to the other end. And then we have inspection controls which have actually been inbuilt into this. So then when you look at the whole industry, so here we find that the terms digital manufacturing and then automation and controls comes into picture. So that is where actually all these technologies what we are talking about, industry 4.0 or IoT based manufacturing, so they come into picture at this place. Okay, now we'll go back little even back into the history. So how all these things have started. So nowadays we talk about industry 4.0, but there were times so where all it started, and the word industry 4.0 or even 4.3, 3.0 or 2.0 were never there. Only after industry 4.0 came, these terms were used. So now we'll go back and then see how all this has started. So in 1700s, so the steam engine was invented by James Watt. So before that, most of the processes which have been done were all done with the force from hand. It's only like a mechanical force by humans which will be applied, and then you get the output. That's all. But then with the invention of the steam engine, so the processes being started, mechanization. So hope you'd have heard this term. Mechanization means, so whatever you're doing with hand, so it is done with the help of a machine. So thus the power, the source of the power is supplied by not with human hand, but with the help of an engine. So in this case, it is engine. So now as we move on, when we came to the 1900s, so the mass production has become popular. So why? Earlier, the demand for the products was very less. Whenever it is manufactured by a renaissance or maybe a artisan, so it will be supplied only to the 2-3 villages around that place. But with the globalization, so the demand has increased and the products need to be sent to different countries. So in that case, they started producing them in large numbers. So maybe in India, we are a bit slower, but in the other countries, right, in 1900s itself, the mass production has started. And then the next revolution has happened when the CNC machines were invented. So the computer numerical techniques, so where the job which has been the tool basically which is controlled manually was now controlled by using the computers. So thus this has brought a revolution, and then the CNC machines have been introduced. So nowadays, if you look at the way how we have these CNC machines, you can look at this machine. So it is located in IIT Madras Research Park. There is a center called Advanced Manufacturing Technology and Design Center, and you can see the size of the machine here. So it is manufactured by Jyoti CNC. So you can see the machine is so big, and you can see the size of the humans here. So thus, with the help of CNC technologies, you can build on one side a big and a very large machine tools of this much size on one side, and we can control them. And then on the other side, if you see, the sizes of the machines have been so reduced. So we talk about what is called as micro machines. So how even that has developed, I don't know if you have heard the term called diamond turning. Have you heard this term diamond turning? Have you heard the term diamond turning? Can you please unmute someone? You can raise your hand if you have the answer. Have you heard what is diamond turning? So hope all the participants are mechanical engineers. Yeah, Frenos, Francis. Yeah, can someone speak? Oh, not able to ask them. Yeah. Shanmugesh. Okay, is this possible? Yeah, now I think you can unmute and speak. Just someone can try. Michael Thomas, can you just unmute and try to speak something? Yeah, so I think that you can unmute and speak. See, it is an interactive session. It doesn't mean you have to just speak. So, who unmuted? You can speak. Vineet Shah. This is our Vineet.
Sir, I am a mechanical engineer, but I don't know what diamond turning is exactly. But I believe it must be some.
Is there anything related to micro machining?
Okay, so all of you are mechanical engineers, or?
No, sir. People are replying in the chat. No, I am a mechanical engineer, but if you see the chat, there are a couple of people who have replied no.
Oh, is it okay? Where do I see the chat? 1 minute.
కానీ మంచి ఫుడ్ మెయింటైన్ చేసిన మంచిగా కానీ ఒకటి ఇన్ఫెక్షన్ ఒకటి ఆ కుక్కలు పిల్లులు అటాక్ చేస్తారు.
So there will be a chat button on the bottom.
Yeah, actually, no. Once I share the screen, the whole settings will look different.
Okay.
If I stop sharing, then my screen will be like what you see, but there'll be somewhere where I should be able to see. I'm trying to figure out. Okay. I am not able to see the chat window. Yeah, can you read what was there in the chat windows? Some of them said no.
Yes, sir. Some people has replied with a no.
Okay. Okay, fine. So I need to adjust according to that, right?
కానీ నన్ను వదులుతలేడు నాకు ఆయనకు
Okay, fine. So I try to keep it as so non-mechanicals are also there. So I'll try to keep myself to a general this thing. Okay, so the diamond turning technology is an advanced technology. So where we'll be able to cut the workpiece by using the diamond tools, and then we can get the surface finish as you see here. It's called as a mirror surface finish. So why this kind of a technology is required is, now when we are sending the telescopes into the space, so where we make the mirrors, so those mirrors we cannot make it with glass and all, because the temperatures which they'll come across in the outer spaces, when it is exposed to the sun, it will be plus 180 degrees, and then when there is no sun, when it is under shadow, so it will be about minus 180, minus 200. That is the range of temperatures. So we need to send the metallic mirrors only. So when you send the metallic mirrors, it should have the reflectivity around 99.99. So how do you make that? So you can see the picture here in the center. So the finish, you can see the whole thing very clearly. So thus we can manufacture them by using the diamond tools. So there actually it is a big challenge because we need to have the tool which is very hard, but at the same time it is brittle. So if there are any vibration, so the tool is going to break. So thus we have to manufacture the machine tool in the right way. Okay, then the next stage, how this manufacturing has developed is what is called as automation. So once the CNC machines have come, so then the automation process has actually started. So where whatever is done by human beings, now it is being done by using the computers and the robots. So thus the automation process has begun. Then later, once the computers have been extensively used in manufacturing, the digital manufacturing has come into picture. So nowadays we have what is called as virtual manufacturing, virtual machining, digital manufacturing, where you can manufacture the products right on the computer. You can manufacture the products on the computers, but they'll be the virtual products. So that is how the computers have been very extensively used in manufacturing. Now, coming back and looking at what is this industry 4.0. So now, as I said, the 1700s or 18th century, so the mechanical production equipment powered by steam, so that has started, and that is the first revolution where the way how the things manufactured have been changed. Then industry 2.0, that is mass production, assembly lines, which are being driven by the electric power. So the next source has become the electric power. So in industry 1.0, it was mechanical power, but now in industry 2.0, it is driven by the electrical power. So then industry 3.0, so where automated production using the electronics and IT has started. And finally, now we are in the industry 4.0, so where intelligent production is incorporated with IoT, Internet of Things, cloud technology, big data, and other technologies. So probably you'd have heard about these things. So that is where we stand. And nowadays people have already started talking about what is called as Industry 5.0. So where the intelligent factories can manage themselves without any intervention of human beings, and they can even become more smarter than the humans itself. That means those who developed it. So the factories, the robots, and the systems can become more intelligent than the people who designed it. So that is where actually we are moving towards. And then when you look at the technology and the skill levels, so usually what is happening is, when it was completely manufacturing is based on the human skills, so the human skill played a very important role. So if he's having, for example, he's operating a lathe, the operator is operating a lathe. If he is not mentally good that day, so the quality of the products is to get deteriorated. But as we moved on to the higher levels, so the skill set what is required is different. and it doesn't directly depend, the quality of the product doesn't directly depend on the skill of the operator, but it is at a higher level. For example, when you move on to the CNC machines, rather than the human controlling the tool, it is going to program it. So obviously the programming skills are required, not the tool controlling skills. So thus the way how things have been changed has been entirely different. So now when you are looking at cyber physical systems, that is IoT based kind of a systems. So we have embedded ICTs, so we have internet protocols, electronics, and all these things controlling the mechanical devices. So thus the skill sets, the way how we look at the things have completely been changed from the traditional manufacturing. So now this question you might all been having because you would have heard the term industry 4.0, but now we have been talking about smart manufacturing. Anybody who knows what is the difference between the smart manufacturing and industry 4.0? Okay, you're all unmuted, so anybody can unmute and speak. Yeah, anybody who want to speak, you can just unmute and speak. I'm trying to understand the participants, so I didn't still get the grip and a level of the participants. So when you speak, we can understand. I think it is Socrates. It looks like one day when he was sitting in a big hall, a very well dressed gentleman came and then sat before him. But he was not opening his mouth at all. It looks like Socrates waited for quite a long time, but that man was not speaking at all. Then finally, Socrates lost his patience and asked, "Oh man, speak so that I can know you. Speak so that I can know you." So sometimes people may dress well and then they may be looking smart, but when they open their mouth, we can understand what they are. So that's the way how now I'm trying to understand when you speak, I will understand like what is your understanding, and based on that I can tailor my lecture. So that's what, but still I have not got the grip on you, or I never understood. So can few of you unmute and speak? See, if it is a physical classroom, I'll just look at you, ask. So now neither I can see you nor I can hear. So I'm not able to move forward in the lecture. So can you speak? Sir Shanmugesh, can you? Yeah, I think you have already unmuted all of them. So anybody can unmute and speak, isn't it?
Yes, sir.
Yeah. Yeah, can somebody speak? No, other way around is I don't
Hello.
need to understand, just I can speak as whatever I want, I plan, but yeah, sorry.
Sir,
Yeah.
sir, is it like both are related, like smart manufacturing and industry 4.0?
Yeah, that
Because
is true.
like industry 4.0 is looking forward for a industrial revolution, which is comprising of smart manufacturing, so that everything can be on demand, and it can be like everything which the even the manufacturing units are like robotics, which is everything like connected with Internet of Things. So
Yeah.
indirectly both are related, which is like 4.0 can be accomplished or attained using this smart manufacturing. That is what I understood, sir.
Yeah, fine. Thank you. Thank you for that. So now Michael Thomas Rex. So yeah, can you please speak? I'm not able to see the chat right now. So you can speak. That's much better.
Sir, are you able to hear me?
Yeah.
Sir, I think that both terms are the same. They're relevant to smart manufacturing. That means working in a remote area and operating every stuff by controlling everything in the remote area.
Okay. Yeah, fine. So I'll give the answer. You can, If anytime anybody want to speak, you can actually speak. So that's what I like an interactive class. Okay. Yeah. So there is nothing much about it. It's only the way how people look at it. So while the term smart factory or smart manufacturing are used basically in US, it is called as smart manufacturing, and in Europe it is generally called as industry 4.0. So Germany and those kind of European countries where it started, so they started calling it as industry 4.0, and then in US they started calling it as a smart manufacturing. So thus both actually refer to almost the same thing, and which is in turn is also known as industrial internet of things, IoT, or internet of things, generally they refer. So all these terms are almost pointing towards the same thing. So now we'll go into the actual topic. So where we are going to talk about the 9 technologies so that shaped and led towards this kind of a smart manufacturing or industry 4.0. So they are advanced robotics, additive manufacturing, augmented reality, simulation, modeling and simulation, then horizontal and vertical system integration, so referring to more factory setups, then industrial internet of things, so cloud computing, cyber security, big data analytics. So these are some of the terms. So some of them are mechanical and others are mostly the theoretical computer science. So those who have computer science background or ECE, about those who know networks, probably they will understand some of the topics better. But it is not just purely mechanical. So if you say I'm a mechanical engineer, so I don't need any computers, then what will remain in the whole manufacturing will be like they're all machines, but like no brain. So someone said, if the controller is not there in a CNC machine, it is like a big elephant which has mechanical strength, but no brain. So it can't be much utilized. So thus, to make the systems effective, so we need mechanical accuracies and robot machine tools and systems, and at the same time it need to be controlled and powered by electronics and computers. So these days there is nothing like pure mechanical, pure computer science, pure electronics. So it's all combined together, interdisciplinary, to make a product to be realized. Otherwise you can't just have only mechanical and only computer, means only programs cannot do. So there should be something to execute. So all these things are interrelated. So we look at them one by one. So now if you look at the area of advanced robotics and artificial intelligence, so actually there was a slide which I wanted to say, but I removed it. So where without artificial intelligence, so we cannot talk about industry 4.0. So that is the way how the systems have been integrated and interrelated so much that artificial intelligence and all these things have become an integral part of the modern manufacturing. So usually if somebody, we go to a layman and say robotics, he thinks that they are all intelligent. Robotics means intelligence. So thus in many places, the robotics and AI have been synonymously used. And if you look at the developments, so what has happened in this field, so they have been used for various jobs. So right from a simple pick and place operations to the assembly to carry out several tasks. So if you look at some of the robots, if you go to an automotive industry, we see these kind of processes which is going on. So what you see here is the robots. 2 robots are making the welding, and the other 2 robots which are on the extreme sides, so they are actually holding the workpiece, and tilting. So maybe you would have observed when you take a screwdriver and when you want to remove a nut or a bolt. So if you just keep it vertical, you may not be able to access it. So what we do is generally we tilt it and then rotate it. So you can access the screw more easily. So that is what actually the two robots are doing. So these are working in tandem. So that means they are communicating to each other and then they are tilting it. So they are called as cooperative manipulators. That means all the four robots need to communicate to each other, and then two robots are communicating together and tilting, then communicating to the other two robots, and they start doing the job. So thus it's all a system where it is a complex kind of system. And not only that, as in mechanical engineers, so you will know what is the importance of inspection. So unless you inspect it and evaluate it, so you'll not be able to improve the manufacturing process. See, now actually when we developed some of the systems, and when we wanted to go to a higher level, we couldn't do that unless we had the inspection information. So thus once we understand the system, then only we can go to the next level. So thus even in inspection, these kind of automated robots are being used. And if you look at the designs and drawings, so the most complex ones are the freeform products, freeform drawings. So most of the mechanical engineers will understand what is a freeform. Like if you look at the body of an car, or even the aerofoil structure of an aircraft, so they're all freeform, but there are no fixed equation to define them. For example, for a circle, so you have an equation. So by means of which you can define the geometry. But freeform surfaces or to the curves, we don't have that kind of a geometry. So now they represent by what is called as nerves. So maybe mechanical engineers will understand what is nerves. Can someone unmute and say what is this nerves curve in geometry in CAD with reference to CAD? Yeah, you can unmute and speak. So you're all being kept open. Those who are working in the area of CAD, what is nerves? Yeah.
So it is a B-spline
Yeah,
used to draw smooth curves.
Yeah, that is right. Can you tell what is the long form of this? What does it represent? What is N? What is U? What is R? Yeah.
Sir, actually,
Yeah.
I don't know exact the definition. I think it is a non-uniform curve, I think.
Yeah, okay, fine. It's called non-uniform rational B-spline curves. Non-uniform rational B-spline. Okay, so that is the curve. So that is an integrated way of defining a geometry. So any geometry you can take and then represent it by using this kind of a representation. It's not like an equation of a circle, equation of an ellipse, but it is a representation. So thus to design that is a challenge, and then to produce the components with that kind of a shape is a big challenge. So nowadays we have the technologies and the machine tool controllers, so which are called as the nerves interpolators. It is called nerves interpolators, by means of which we can make the tool to trace the geometry what we have given in the CAD drawings. So thus we have an advanced level of controllers. Then when you look at the robots, it is not robots these days. So the term cobots is being used very popularly. So what is a cobot? Cobot is nothing but a collaborative robot. So what is collaborative robot? See now, for example, when you go to a construction site, if a very big mass need to be lifted, so what they do is people will hold from two sides and then they cooperate and then do the job. So that is what actually the robots can do. It can be one robot and one human being, or it can be two robots. So nowadays, actually, in IoT systems, where we can have the robots and the machine tools or the computer systems can communicate with the human beings. So thus, in the cobot, we can have the robot and human being working in tandem, so cooperating. So that is called as the collaborative robots. So here we can see that whenever the human being raises a hand, even the robot will raise a hand. So when it lowers, so the robot also can lower it. So thus in the advanced systems, so the robots will understand the systems around it and then they act cooperating with the physical systems. So thus a robot is an mechanical device, but it understands the physical systems like the human beings or the machines which are there, and then they interact and collaborate. So these are the levels of advancement what we have. So here all these are some of the examples. So how the robots and the human beings can interact. So you might have heard the definition in IoT, Internet of Things. So usually if you look at the manufacturing systems, so we have a machine, so we have a robot, so then we have the material handling system, everything. So earlier, so these were all considered as the system. And then the human beings were outside. But now in IoT, it is not like that. Even the human being is inside the system. So the machine can interact with the human beings. So the machine can interact with the material handling system. The material handling system in turn can interact with the human beings. So all have become an integral part in IoT. So here is a video which shows how the advanced robots are called as a self-assembling. So you can make them so intelligent and then you tell that, okay, you need to be formed as a car. So they join together and make a car. Or you want to say that, okay, you build up like a pillar. So they all will become the pillars. So this is called as a self-assembling robot. So that is the advancement what is there. So now you can see this one. So they move independently and they get assembled. They have capability to move, orient, and get assembled. Okay, so thus the systems can handle by themselves, and then they can function whatever the function which is required. Then the next advancement in manufacturing is additive manufacturing. So where we can produce the components by layer. So sometimes it is also called as a layered manufacturing. So where the material is, see, usually if you look at the mechanical way of manufacturing the components, it is a subtractive manufacturing. So where we take a raw material like this, so then we cut and remove the material. So whatever the features we want, we'll make on that. But in additive manufacturing, it is not like that. So now if we need a component, so I put a layer of material like this. So then over that, different layers have been put, and then we build the walls wherever it is required. So thus additive manufacturing is building it layer by layer, but generally the traditional way of mechanical manufacturing is subtractive manufacturing. So nowadays, if you look at the components what have been manufactured, so you can manufacture complex shapes like this by using additive manufacturing. Earlier, additive manufacturing was used only for like rapid prototyping, only as a prototyping and as a just as a model. But nowadays we find that they are being used as a functional components. That means like in a machine tool, if a component is broken, so we can actually make it by 3D manufacturing and then fit it to the machine, and then the machine starts functioning. So that is the way how the technology has developed. No more 3D printing is just a rapid prototyping method, but it is manufacturing the components and the products which are used in practice. Okay, I think there are different ways how we manufacture that. We will not go into those details. So nowadays, even the aircraft products are made by 3D printing. So if you go in Airbus, so there we see that most of the components which you see in the interiors of the aircraft are all made by 3D printing. And also this 3D printing technology, it is rather the metal 3D printing is being used for manufacturing of turbine blades and also for repairing of turbine blades. So if you look at the turbine blades in an aircraft, so they are very complex structures, and then if even one of the blade gets damaged, they have to change the whole thing. That will be very expensive. That is called as a blisk. So where with the blades and the assembly, so you have to change whole of them. But nowadays we don't need to do that. So we can actually put the material wherever it is required and they can be used again. So even people are nowadays manufacturing the customized helmets. So if you look at the sportsmen and all, you would have seen the car racing or even bike racing. So they'll be moving very fast. Sometimes untowardly, the accidents will happen. They will fall and then they will get up and then walk. But in your bike or in our bike, if you go and fall like that, probably will not get up, even in spite of wearing a helmet. Why it is? Because the sizes of the helmet and the truss, whatever they wear, there's been so customized that there'll be no gap between the head and the helmet. So thus, even when they fall, the impact on the head will be minimum. So that is the way we need to manufacture the helmets and the other customized products. So how they make is generally they take the scan of the person and then they manufacture the helmet exactly to fit to that size. So these are all possible with the 3D printing technology. And the next technology which has led to this kind of an advanced manufacturing is what is called as modeling and simulation. So modeling and simulation. Okay, now participants, can someone define what is modeling and simulation? Yeah. What is modeling and simulation? So what is a model? So Satish from yeah, please, yeah. Yeah. Yeah, somebody started speaking. You can please.
3D representation of
3D representation of
a concept which we want to design.
Okay, so it can be a concept or it can be a physical thing. So, if I have a okay tower, Eiffel Tower you take, I can make a model of it. So thus there are different types of models. It can be physical model, mathematical model, or any representation. So that is a representation. So I agree. So what is simulation? Model is a representation. Yeah, what is simulation? Yeah.
Simulation is something that predicting the behavior of the system in a real-time condition.
Yeah, very good. So you have directly put it. So simulation is nothing but, so we are going to make the model. So model is required for simulation, and that model actually behaves in a similar way as the physical system. Okay, so one of the interesting example is what you see on the bottom right side. So this is called as a crash test. So any automobile, so before being implemented or produced in mass for the use of the public, it need to undergo what is called as a crash test. So in crash test, what they use is, earlier days, they will take the physical car, actual car, and then move it at a higher speed, whatever is the required speed, and go and ram it against an obstacle. And then, so usually they put a dummy here, so like the passengers, and then see what is the damage which is caused to the passengers when that kind of an accident happens. And then they will also study what is the damage which is caused to the automobile, and then if any structural design need to be changed, so they will make the changes. Thus crash test is a very expensive and takes a lot of time. But nowadays what has happened is, by using the simulation, you can make a CAD model, you can have an FEM introduced into it, and then finally go and ram on the system. So it is not on the physical system. In the computer itself, you ram an obstacle, and then we can study actually what is the stress, what is the strain, so what is the damage which has been caused even to the dummy which has been kept there, and we can analyze it. And finally, to get the certification, they have to make finally one test physically with the actual car, and then they can assess the damage, and almost it will be right, it will be satisfying all the requirements, then they can go for production. So thus the simulation has actually led to what is called as the digital way of looking the things, and then to digital manufacturing. So thus even machining of the components, you can do it right on the system, and then later when you implement that to the actual system, so you get a good quality products. So thus simulation has played a very important role in manufacturing. Okay, so just to ask a question, probably you might be knowing about it. Do you know what is the difference between the simulation and animation? You might have heard this term, animation. What is the difference? You can say what is animation and tell the difference. Yeah, please.
Animation is more or like the whatever happens will be given according to our input, but in simulation we will be getting some information like out of simulation. But animation,
what information?
like like if it's a finite element thing, we will get whatever stress values, etc. If you are computing for that, you will get those values.
Yeah,
But in
yeah,
animation, whatever thing is that we are giving the inputs.
yeah, you're right. Okay, so in animation, it's only a graphics. So you won't be able to see, like, for example, so when a dinosaur is walking, if you want to know what is the stress or what is the load it is exerting on the ground, you cannot find it out. It's only a visual appearance, it's only a graphics. But if it is a simulation, actually we can calculate the engineering properties like stress, strain, or other properties, even in momentum and all these kind of a things. So thus, simulation is important for engineers. So animation, maybe for those who are making movies or graphics, so for them it is. But always remember that our simulations front end is animation. So now, for example, even in FEM, you think that you have a cantilever beam, so where you have exerted a cyclic loading and then it is vibrating. So if you want to see that vibration, so we need animation. So thus both technologies are complementing, but simulation is at a higher level where we can see the engineering properties. Okay, the next level of simulation is actually called as virtual reality. So where this term is an yeah. So virtual reality means actually the term is by English wise it should not be right, because virtual means which is not there, reality means it is there. So virtual and reality, but to put together, actually it is making a lot of applications here. So now in the simulation of pilots and the training of the pilots, in all these things, actually we have what is called as the virtual reality. So where in computers, like for example, if you take a computer gaming, so you would have seen like the driver there will go very fast, hit another car, so then he will tumble, then in the computer itself, so he will get up, take the bike or a car again and keep driving it. But in virtual reality, it's not like that. The person who is operating that computer also becomes the part of the environment. For example, while training the pilots, so if the pilot actually take the flight very steeply, so actually the simulators will make him to feel that acceleration. So thus the human being or the operator also becomes a part of that computer environment. So that is called as virtual reality. So nowadays there are so much advances. So even here in Chennai, we have what is called as a design cave. So that's by Caterpillar. So we took some of the students and then visited a few, rather nowadays, no, years back. So we went there. So they show how actually the whole system will be there, and we can actually virtually walk into the system and inspect it, see it, assemble it, machine it, cut it. All these things we can do actually by using this kind of an virtual environment. So that is called as a design cave. So computer aided virtual environment. Okay, so the next technology which has come into existence is called as augmented reality. Augmented reality. Okay, now I need the participants, so maybe non-mechanical participants can answer this fast, I think. What is augmented reality? So you see Robin Abraham from EC department, maybe faculty, but can you please say what is augmented reality? So mics are open, you can unmute and you can speak. Or anyone else is also fine. Oh, they have sent a message, but where do I see the messages? Yeah, can someone speak? What is augmented reality? Any answer?
Sir, actually, it may be using the image capturing using the camera to giving some guidance. So for example, recently Google announced navigation system based on this augmented reality.
Yeah. So if it is only a photo, that if it's only an image, that will be a photo. But even nowadays, cameras are coming with augmented reality. So what is that? Cell phones are coming with augmented reality. Okay, so to save time, you can see the definition here on the screen. So a technology that superimposes a computer-generated image on a user's view of the real world, thus providing a composite view. Okay, what is the meaning of this? So you can actually have a live, so it is a real-time picture, it can be a video. So where when you're taking a video, so this, whatever the picture, what you are seeing here, that character is not there on the road actually, but you can put it there. So that is actually the road image, what you are seeing, the video or the image is the real one, but you can also put what is not there. So maybe this is a fun for taking pictures, and you can put a character beside you and take a picture as if maybe that is can be a person. You can put yourself there and then take a picture. It may be good for fun, but in engineering, how they use is actually one of the company here, maybe Caterpillar. So what they did is actually there were tunnels, so where the earth moving equipment need to be moved. So now if they would have taken directly these earth moving equipments into the tunnel, so probably they could have got struck. But what they did is they took the images and video of the tunnels. So then they superimposed the image, actual size, real sizes of this earth mover. Then they simulated, moved, tried to move inside and then see. And finally, when they were satisfied that this can move inside and carry out the works, then only they moved. Otherwise, they could get struck and then removing it would be a bigger task. So thus, many of the mechanical tasks can be performed by using, simulated by using this kind of an augmented reality, and then can be put into practical use. For fun and all, you can have pictures or videos, putting whatever it is there, like you can take the video of your house and put some VIP coming into your house, kind of things also you can make. So
Sir, one doubt is this, can I ask it, sir?
Yeah.
So once if you take a picture and if you're changing the face and all, that comes under the augmented reality?
No, actually face, that is not
Changing the
actually
face to an older one or a younger one.
Yeah, but that is not augmented reality. So augmented reality means reality is there. So you put something along with that. Yeah. So by using the graphics, actually nowadays we have a lot of technologies. So where we can just use the advanced graphics technologies to make the things look different. I think even yesterday, I think one of our Indian scientists have found, like if I give you a picture of you at the age of 50, and maybe we didn't had a picture when you were at 20 years, think that we didn't had a picture. So we can simulate it either backwards, or even if you want to look at how you will be when you are 75. Both are possible by using the advanced graphics. So you can come backward and see at 20 years how you are looking, or at 75 years how you look. So that is all advanced graphics technologies. Augmented reality is take the real world, put something which is virtual there, and combine both these things. So that's how I said the augmented reality can be used in manufacturing. So even in assembly practices for training and all they use, and they say that they can get an improvement and accuracy is up to 96%, and they can do the works faster by 30% if they get trained on this augmented reality manufacturing. So here in IIT Research Park, we have actually augmented reality based welding kit. So you might have seen, so even in our engineering course, so we did welding. So what happens is while doing the welding, usually the rod gets stuck to the workpiece. You might have observed. So only when the experienced person takes, he will smoothly do the welding, but we will not be able to do it. But we can train the person on the augmented reality welding practice. So thus he can, once he has got the practice, he can go and do it much better practically. So thus this kind of a technology can be used in various mechanical engineering fields. So the next pillar is horizontal and vertical system integration. So with the help of computer integrated system, so the whole of the systems have been integrated. So you may ask like what is horizontal and vertical systems? So usually if you look in a manufacturing environment, so if you take an industry, so where we have casting, heat treatment, rolling, cooling and all. So each one will be like a pillar. And then in that, we have subsystems which need to be done. So where rolling means you need to have a hard workpiece and then it actually gets rolled, pressure is applied, recrystallization happens, then the flow stresses will be generated, then grains regrain, grain growth will be there. So all these things will be happening. So it is the processes on one side and then inside the changes which will be happening. So all these things actually can be combined together and integrated. So if the systems would not have been integrated, so we cannot talk about the systems what we have now. So thus all the manufacturing processes and systems have been integrated and thus we have a unified kind of a factory setup. So where we can use the computer. Another example I'll tell you, like for example, sometimes you might have heard telling that the one of the car company has recalled a particular model. So why? Because they'll give a reason that the fuel injector which was there in this particular car was defective. How do we know that? You know what, in the digital manufacturing, what they does is every component which goes into the product will be traced, will be noted, and then they know what engine number has gone into this car and what the fuel injector has gone. So what kind of components, each one will be counted. And thus if there is any defect, that whole batch will be recalled. So we have such kind of a data. But earlier it was not like that. Usually in the design section, the data used to be different. So they would have made a version 5, but on the shop floor, when you come only version 2, they'll be manufacturing the component, same product, but they keep revising. But nowadays it is not like that. So the database, actually, if you look at the integrated system here, so the data is the core. It is not the physical system, but data becomes the center of manufacturing. Thus, if you make a change in the design section, so right from there to the process planning or to the shop floor or to the inspection or even to the customer, it's all simultaneously, it will be changed. So thus, nowadays, the industries are the manufacturing, the machines are not the core, but rather the data has become core. And that is how actually the IT revolution has played an important role. So in IT, what is their important thing is that data. So data is like money. So thus the data has become the core, and that is the reason we are able to implement all these technologies very easily into these systems, into the manufacturing systems. Otherwise, manufacturing is mostly, it would have been like a physical and a mechanical system, but nowadays it is no longer that. Okay, so about IoT, I think I don't need to tell much about it because you all would have been hearing right from the first day. Can someone quickly tell what this IoT and what is its influence on manufacturing? Yeah, we have about 15 minutes to go. So I have three more things to tell. But IoT, I don't need to explain because already you know. So if somebody can just consolidate and say what is this IoT and what is its role in manufacturing, we'll move forward. Yeah.
So for example, if I'm saying with respect to like maybe health monitoring,
Okay.
the role of IoT, if I'm saying it might be having a number of sensors, set of sensors, maybe vibration sensors, etc., which will help me keep track of what is really happening on my device real time, and I'll be able to access it anywhere over internet, which reduces my maintenance time. Like preventive maintenance, it will aid me in preventive maintenance.
Okay. So now what you're telling is a sensor based kind of a technology. Why it is called IoT, Internet of Things?
So the data will be available in cloud and it will be accessible anywhere all over the world.
Okay, so something closer to a cloud computing, obviously that is also a part, but why it is called Internet of Things? Things is coming, no? So what is that? Why is that?
Because those those devices that is connected over internet will communicate within each other.
Yeah, that's right. So here they are the things which are interconnected, and also actually in this figure, if you see, the human being also need to be kept. So even a human being becomes the part of it. So Internet of Things is that the networking of physical devices that are capable of communicating among themselves or with the external environment. So for example, think that a device is located in a enclosure and the temperature is getting increasing. So that machine or a device can talk to the air conditioner and say my temperature is increasing, so you increase the cooling effect. So like that the systems can talk one between the other. And also if it want to give the communication to a person, the supervisor, it can send an SMS telling that my temperature is rising. So that is how the things can communicate to the other things. But earlier, this kind of a concept was not there. Like human beings used to interact with the computer systems. But in this one, they themselves can talk. So if you even go to a industry nowadays, we have what is called as AGVs, automated guided vehicles. So where once the load is put onto that, it actually talks to the other system telling that, okay, the workpiece has been loaded, so now you can start moving. So thus the systems themselves can communicate without the interference of the human being or the external interference. So they can talk and talk to one another, talk to the environment, talk to the human beings also. So all these things are connected, and that is the reason it is called as Internet of Things. It's not only Internet of computer systems, but it is Internet of Things. So a washing machine can talk to a TV. So a TV can talk to a tube light. So like that. And how it is possible is with the help of sensors. So thus the sensors play an important role. That is a sensor technology, multi-sensor technology. All these things are there, but that becomes the foundation for the Internet of Things. But Internet of Things is not just sensors. Sensors are an integral part of that, or the enablers for that to communicate. Okay, IoT is industrial Internet of Things. So these okay basically apply to the systems in the industry. So I'm not giving more details because already your title is that. So every speaker would be probably speaking about that. So you can just see a video of a car, how it communicates to the operator. Okay, so whether you understood fully or not, but what is happening here is that that car actually, when the person, the owner, when he comes, it understands, it opens the doors. So then it asks which place you want to go. So you just tell the place, it keeps the program, it reaches the destination by itself. And then it says, okay, have a good day, you arrived early, and then it closes and then waits till the person comes again. So thus the car is communicating with the human being. So thus the humans become a part of the computer environment. Okay, there is one more technology which is called as a digital twin. I don't know if you have heard about it. If somebody would have heard what is a digital twin, can you quickly say what it is? What is a digital twin? In aviation industry and even in big power plants, people have been talking about these terms. So can someone say what, have you heard this term? What is digital twin?
Yeah, again, I'll try to say that with an example.
Yeah.
So suppose I'm having an turbine. So I'll have temperature sensors and maybe stress sensors mounted onto that turbine, like on critical parts of that turbine. So I'll be having a digital CAD model or something like that, or a model in my system, which I'll monitor continuously. So whatever stress or temperature that my turbine undergoes will be reflected in my digital counterpart.
Yeah.
So I'll be able to monitor this digital counterpart, and again, it will contribute to this predictive maintenance, etc.
Yeah, okay. So you're precise, right? So what is digital twin is that if there is a physical system, so there is a similar computer kind of a system. So you may ask, what is the use? So by using this computer system, I can predict the behavior of the physical system. And not only the behavior, now for example, if I have a digital twin of a aircraft engine, so now, whenever we are going for a flight, we can know what is going to happen when it runs for the next 10 hours. So whether it is going to be fine, is it going to fail, or which component is going to fail. And if we actually run the engine physically in the same kind of an environment, usually what is being happened on the computer actually happens on the system too. So thus, the behavior of the computer system is exactly like the behavior of the physical system. And that is the reason it is called as a twin. So if it fails in the simulation, so the next hours when you run this system also, it is going to fail. So thus, we can reproduce the physical system on the computer, and that is called as the digital twin. Okay, so there are several impacts on by using this one. So as one of your participants said, it is a predictive maintenance, which has been very extensively used to predict the behavior of these systems and avoid a lot of accidents and failures by using the digital twin systems. So you can just see a small video here.
by remotely predicting service, they reduce response times from 5 hours to 20 minutes. And
Okay, so though it is a promotional video by them, but we understand. So the important point, what he has said is that the smart manufacturing powered by IoT. So that sentence is very important. So now as you're undergoing the short-term training program, you should be able to relate between the manufacturing and the concept of IoT. So thus to enable the industry 4.0 or the smart manufacturing. So it is being powered by IoT technologies. So unless you have the sensors and then the powering by these technologies, you cannot realize the smart manufacturing or in industry 4.0. So that you should understand. Then the next one is the cloud computing. So where we talk about, I think already one of your participants has said, so the data is stored in the cloud and you can access it everywhere. But earlier it was not like that. You put it in your hard disk drive. So there you go to another place for presenting, you'll say, oh, I've forgotten my USB. So now I don't know what to do. But nowadays it is not that, it is being stored. So you can access it from anywhere. Okay. So the cyber security is another big challenge. So where the data which is there in the cloud, so that need to be protected and it should be given to the users where it is required, and it should not be permitted for those for whom it is not intended. Like for example, the bank account, so you can know your account, but your friend need not access it. So that is where the security plays a very important role. And the last one, what I'm going to talk about is the big data analytics. So where a lot of, but what do you do with that? How do you infer the right information, useful information? How do you extract it from the lot of data which is available? So that is actually done by the big data analytics. Okay, so I'm not going to go into detail because it's exactly 11 o'clock. So what we are expecting is that in future, we look forward for development of new types of technologies, processes, and systems that will further revolutionize the way how we look at the products, how we interact, the machines will interact with the human beings. So that is how actually the whole traditional manufacturing has been started, and then it has been moved to this state. So where we talk about the smart manufacturing and the industry 4.0. Thank you for your attention. Thank you, sir.
Thank you very much, sir. Any questions from the audience? Anyone like to interact? So I think no questions.
Okay.
So thank you very much for the wonderful session and the detailed session on the 8 pillars of manufacturing, sir. So let me invite Akash Palsave for the vote of thanks.
So thank you so much, sir, for your wonderful session. Well, I'm very sure that all the participants gained a good foundation in smart manufacturing, simulation, Internet of Things, and all other related areas. So on behalf of Mechanical Engineering Department of Ishijodi College of Engineering and Technology, I extend our sincere thanks. Thank you, sir.
Thank you.
Thank you very much, sir.